Okay, so I have to find my screen just a second. There we go. We're not on the right screen. So this lesson is 7.4. Now I would like to say to you, this material is not on the quiz. Okay, this is not on the quiz. I don't expect you to know any of it for the quiz. So quiz, you already have the paper, substitution, elimination, graphing, 3 variables, linear and nonlinear, and story problems. Okay, so it's a good enough size quiz. So lesson 7.4, we are going to talk about something called matrices. It's actually not difficult. None of this is difficult. So we've talked about yesterday the fact that we can solve things that are one equation with one variable, 2 equations, 2 variables, 3 equations, 3 variables. We could do 4 equations, 4 variables. Nobody wants to do that. Okay, but it's possible, and so we're going to learn an easier way to do that. Also, what we're able to do with this way is to solve things that are previously unsolvable, basically. So we could solve, like I said, we can do 1 equation, 1 variable, 2 equations with 2 variables, right? 2x minus y equals a number. What ones that we did yesterday. But if I gave you something like 2x plus 3y plus z is equal to 4, and 5x minus 2y plus 3z is equal to 20, you'll be like, no thank you, because there's 3 variables but not 3 equations. This is actually a solvable thing, and so we are going to get into how do you solve that, and the way that we do that is using something called matrices. So let me give you some background. So you can't use a matrix unless you know what a matrix is. So background first, and then we'll talk about how you use it. Okay, so the word matrices is actually the plural. Okay, it's actually a plural. So the single word is matrix. Okay, so the definition of a matrix it's not a very helpful one. It's an array of numbers. Okay, they are in a particular order. It's basically it's the mathematical version of a spreadsheet. Okay, it's a mathematical version of a spreadsheet. So if you've used Google Sheets or Excel, it's like a spreadsheet. So here's an example. This one does not have any meaning. It's just an example. It has a square bracket. That denotes where the matrix starts and ends. So let's do this one. 3, 5, -2, 1, 0, -0.5, 3, 7, 6, 2. Okay. So that's a matrix. Okay. Now, again, I just said that this matrix does not have any particular meaning to the numbers. We will get into the ones that have meaning. Actually useful in some upper level math, analysis type stuff in science classes use this. Like if you were going to study some environmental things in biology class, like there's uses for matrices in that. I don't really want to go into it right now, but there's use for it. So a couple things. A matrix is made up of rows and columns. Okay, so the rows go side to side, columns go up and down. So how many rows do we have? 3 rows and 4 columns. So there's something you're going to feel like, well, first of all, let's go with this. We name matrices. So we name them not just with the letter, but what letter with those square brackets so that you know that we're talking about a matrix. Tomorrow, whenever we get into the next 7.5, which won't be tomorrow now that I look at my notes, also with the quiz tomorrow. We get into 7.5, we do math with matrices. It's very similar to vector math. So like when we added and subtracted and multiplied by a scalar, when we did vectors, matrices are similar math. So Like, it's nothing to stress about, but we're not going to do the math on it today. So the dimensions, this is an important thing. Like, you're going to be like, this is stupid. It's actually important. So the dimensions of the matrix are rows by columns. So if you've ever taken wood shop, like, that, like, if you're talking about a piece of wood, it's a 2x4 because it's 2 inches by 4 inches and some unknown width, 2x4. So rows, columns. So the dimensions of this matrix, the dimensions of matrix A, he is a 3x4 matrix. Okay, rows first, then columns when we talk about it. Great. Okay. Okay. So what are the dimensions of this matrix here? Yeah, he's 2x3. Okay. Like I said, you're going to be like, this is dumb. There's a reason that we talk about this. So just bear with me a second. Okay. What's this? What's the dimensions of this one? 2x1. Rows first. 2 rows, 1 column. So 2x1. Okay. Rows first, then columns. Okay. Now, there's a thing. This is important. Okay. So this guy, what's his dimensions? What are his dimensions? 3x3. I like those ones. You don't have to think about it. This is actually called a square matrix. Okay. Square matrix for obvious reasons, right? Because it's 3x3. Same number of rows, same number of columns. Okay. This right here is called the main diagonal. Okay. Because you could go the other way diagonally, and it is also on the diagonal, but the main one goes top to bottom. So top right, bottom left. So just terminology that you gotta know. So we're gonna talk about one more thing. This one is, I think it's on a quiz or a test. In fact, I know it's on a quiz or a test. It's not difficult. It's just some people might be like, why are you even telling me this? When I went to college, and I had to take an entire class that involved vectors and matrices, okay, because they're kind of related. And there was some notation in there that I was like, I've never seen this in my life. I had never seen a matrix in my life, honestly. But I was like, what is this? And it's not hard, so I figured I might as well teach you this. So you could say something. So here's matrix A. I'm going to go back and talk about this guy. There's notation, like if I asked you to find A 2, 3, A 2, 3, that is actually the notation for a specific entry in the matrix. Okay, that would be row 2, number 3, column 3, actually, right? So what number is in matrix A, row 2, column 3? We're in matrix A, back at the beginning. I wonder where you guys are getting your 4 from. This guy up here at the top. 0. Yep. So how about we'll stick with A. A 3, 1. It's row 3, column 1. Yep. And then how about A 1, 2. Okay. What about A 4, 1? That's not possible, right? Because there is no row 4. Okay, so not possible. I would not ask you that just because it would be stupid to do that, but just you get the point. Okay, now we use matrices. The reason we want to talk about it, like I said, lesson 7.5, we're going to talk about matrix math. So some of these come back in when we're talking about matrix math, some of these terms, some of the terms we use now. We use matrices to solve systems of equations. So what this is going to do, it's going to add another, like we know we can solve by substitution, elimination, and graphing. This adds a third way to solve systems. Okay, so we're going to start with some that are easy that I probably would solve using substitution or elimination, but we're going to start with easy ones. So if this is my system, I just got to think a second. So let's go. Okay, so this is my system. If I'm going to use a matrix to solve a system, I have to represent this with a matrix. So I'm just going to show you this because as soon as I show you, you're going to be like, oh, yeah, well. Okay, this is something called an augmented matrix. That's a funny word. Okay, so I'm going to give you a little bit of information. Anybody play guitar? No guitars. Okay, if you get into music theory, there's something called an augmented chord. I don't know if you orchestra people know about that or not. An augmented chord is a regular chord that you've added. A chord usually has 3 notes in it. You add a note into it. Okay, and so it's instead of 3, it's 4. So to augment something is to add to it. People have augmentation surgeries when they add things to themselves. So augmented matrix, something is added. What's added? Which is what? No. Okay, so in that matrix, what's different about that matrix and the other ones that I showed you? It has a dotted line. That's the part that makes it an augmented matrix, okay? So when we put it in our calculator, your calculator will not do that. This dotted line is what tells you that this represents a system. So the presence of the dotted line lets you know that this matrix represents a system. Okay, so the question that I have for you is, do you see how those two things are related? Like, where did the numbers in the matrix come from? What are those called? Coefficients and the equal sign, right? The coefficients and the equal sign. So the important thing to know, if you are going to make a matrix out of a system, is that they have to be lined up. So all the X's, all the Y's. Okay, because you can't have them in opposite orders or you'll be solving a different system. Okay, so do you have questions about this? You get what I'm throwing at you? Okay, so the way that we solve this in our calculator, let me get my other calculator. There is a matrix button on your calculator. You see it? It's on the left side. Okay, so it's second and x negative 1. That's x to the negative 1 power. So do that. And you can see that it brings up. Hey, Andy, you want to do this too? Yeah, with that calculator. Christian, where's your calculator? Go get it. Oh, my word. It's math class. Get your calculator. So what you've got here, these are matrices. You see the square brackets there. We don't want math yet. What we want to do is edit. Okay, and so when you go to edit, Don't worry about the math. Like I said, this is all the things you could do with a matrix. We're not going to do most of them. Okay. But if you go to edit and hit enter, you are allowed to go in and change the matrix. So what are the dimensions of this? It's 2 by 3. So the whole matrix is a 2 by 3. So you'd put in the 2 and you arrow over and you put in the 3. And you can see that it builds that matrix at the correct dimensions for you. What? No. This one? It's not, I just said it's not going to. When you put it in your calculator won't do that. You're the one that has to know you're doing a system. Okay, so put those in. So just hit your number, and as soon as you hit enter, it will jump to the next. It goes across the row. So 3, enter, and hit enter, and it will do that. So notice, now this is just randomness, but look at the bottom, it's using that notation. That's A11. There's A12. It doesn't matter, but that's the notation I was telling you about. So once it's in, you have to actually, I don't know, just a second. Let me see. You can then, just a second. Yeah, you can't. You have to quit. No, you have to quit. Trust me. I just tried it. Okay. So otherwise you're still in that matrix, and whatever you do will change the matrix instead of do the other things. Change, I know, changing the matrix. Hello. Yes. Uh-huh. Grayson. That was Paul. Flip the red thing on outside the door so you can get back in. Okay, so now we would like to, now we're going to go back into matrix and we're going to pull up some math. Okay, now there's this whole list. It's math, and I just like to go up because it's down to the bottom. It's B is the thing that we need. Okay, so hit enter. Whoops. Shoot, I screwed it up. Math, and I'm going up. There we are. Okay, now this is, it's a pain in the butt, but you got to go back into matrix and tell it that you want matrix A. So hit enter. You're actually in that matrix menu 3 times to do this process. Okay, so when you have this RREF, you can hit enter. Okay, if you hit enter, okay, if you hit enter, you get this. So you get a matrix. So I'm going to talk to you about what RREF means. You don't, like, this is not. Hi. Oh, thank you. Perfect. That's as good as I would have gotten in my house. It's mine.
No, you said that's as good as I would have gotten.
He cleaned it. I didn't have to clean it. Yeah. Can I make you some pancakes? I don't have any pancake batter.
We have muskmelon at my house and I want some.
That's so random.
That was so random. So the RREF stands for reduced row echelon form. Okay, what that means, you don't have to know it. But I want you to be careful because when you use that matrix menu, right above that was REF. Okay, you need the double R because it will not solve it fully. So reduced row echelon form means, let me write down what we got so I can illustrate for you. Means that in the square part of this matrix, those numbers are going to be zeros or ones. If you just use our REF with one R, it won't do that. This means this is the simplest possible thing that it gets. Now you're like, why do I care? Because this gives you the answer. Okay, so if we put this is our answer matrix, if we put this back into a system of equations, okay, so we started here and made this matrix. So now we're going to go backwards. what's this system? Yeah, it's x plus 0, 1x plus 0 equals 5, and 0x plus 1y is equal to 2. And it just gives you your answer coming out of there. Okay, this is why it's important that your x's and y's are in the same order, because if they're not, then you're solving an entirely different system. You have a different answer. Okay, so it's super easy. Here's a nice thing for you. I'm gonna teach you a little bit of a calculator hack that will save you a couple steps anyway. So let's solve this guy. Nope, I don't want to do that one yet. So let's say we're gonna do 5x minus 3y is equal to -1 and 1.5x plus 3y is equal to 7.5. Okay, now here's that's only slightly cool. Okay, but if you go back into the matrix menu, first of all, let's talk about this. What's the matrix you're going to put into your calculator? 5, -3, -1, 3, 7.5. Okay, right? There's my dotted line. It's a little crooked. Okay. If you go back into your matrix menu, make sure you hit edit, because I always do that. You got to go over edit. If you put it in the same one, you're going to save yourself like 7 steps. Okay, so go ahead and put that in, then don't do anything. Oh, shoot. 2 by 3. It should type right over. So, well, okay, and then don't do anything. Look, what you already have on your screen is RREF of A. So go up and grab it and hit enter. Then you don't have to go back into that matrix menu twice. There's your answer. Do you get what I'm saying? So use what's already on your screen so that you're not retyping. That's going to save you a lot of time.
That's not right. That's why it doesn't work right.
So here's the thing. Here's the thing with these. The only way you're going to catch a mistake is if you're checking your answer. What I would recommend doing, this is what I do because I don't always check my answers, if that's the honest truth. I just double check before I quit out of here to make sure I have down exactly what I wrote down. Because the most likely mistake is you put it in wrong mistake. Okay. So your answer matrix is 1, 0, 1, 0, 1, 2. So your answer itself is what? 1, 2. Okay. Now, here's the nice thing. Now, again, you guys, I probably, especially with this one, I would have just solved it by elimination because it already eliminates. 2 by 2s, it's probably more efficient to just do it unless you've got terrible decimals. But we can do 3 systems, 3 equations, and 3 variables. I don't want to have to solve those things by hand if I can solve them with my calculator. Okay, so let's do this one. Plus y minus 4z equals 29. -4x minus 2y minus 3z equals 17. 6x minus 3y minus 3z is equal to -24. Okay, what size matrix is going to be your equation matrix? 3 by 4, right? Because we got 4 numbers in there because we always got that equal sign in there. So -6. What is row 1, column 2 going to be? Yeah. -4, 29. -4, -2, -3, 17. 6, -3, -3, -4. Now, listen, you can save yourself, okay, before you start putting things in. What you might consider doing, you don't have to, but what you might consider doing is putting anything that's a 3x4 in B. So that you, when you go back, it doesn't matter to me. I guess you got to get in either way to edit, right? It doesn't matter. Never mind. Do whatever you want.
Gave up so quick.
I did. I was just thinking, I don't think it gives you any advantage. You still have the same amount of getting into there. 6, -3, -3, -4.
The bird outside.
Mm-hmm.
Thank you for that. Absolutely.
Mm-hmm.
Well, Javon, you immediately started critiquing her as soon as she walked in the door. I was pretty mad too. But you did. Or was it Grayson that did that?
They both did it.
Yeah, they both did it. Okay, that's
several
worse.
times. Yeah, that is how that.
Wow, that's number.
Yeah, Javon, I think you did it wrong.
Yeah, that's not that big.
What didn't you do wrong?
Okay. So I want you to notice that the zeros are on the main diagonal, which is why we're talking about main diagonal. Zeros on the main diagonal, everything else is answer. I said zeros, I'm sorry. Ones, zeros everywhere else except the answers. So your answer, I think we did this one yesterday, is -4, 1, -1.
So wait, can I do this on the quiz?
I think that I'm having you do one of these. I think I have you do the 3x3 by hand, but there's no reason you can't check your answer. Right? You have to show your work. There's a story problem though. No, I think I said no on the matrices on this quiz. Pretty much. But you can check your work. Now, let me say this, okay? As long as we're talking, you cannot use matrices if there is a power at all. Okay? This only works for things that are single powers. So don't think you're going to, when we take the test, so when we take the test on this, you can use whatever you want. Okay? Quiz, you're going to have to do it by hand. Test, you can use however you want. But you have to be able to solve a nonlinear one by hand because a matrix won't do that.
What about ones where you have three equations, but not all?
We're going to go there. Okay.
You put 0 in, right?
Okay. So let's say, we have this. So you're going to go -x minus 3y minus 6z equals -29. Z equals x plus 3y plus 6, and y equals x minus 7. Mm-hmm. Okay, so what are you going to need to do here?
Move stuff around.
You've got to move stuff around. Okay, so it is so important that the only, I don't want to say number, the only non-coefficient number, the constant has to be by itself. Okay, and everybody else has to be on the left-hand side. Variables and their coefficients have to be on the left in order. Okay, so this guy's going to stay the same. I'm just going to rewrite him because I want to. Okay, what does the bottom one become? Oh, yeah, I wouldn't have thought of that, but yep. -z equals -6. So Kira, minus the 6 and minus the z. Do you know what else is okay? Is if you would have had -x minus 3y plus z equals 6. Both of those will get you the same answer because they are equivalent equations. Okay, and then what does this guy become? Yep. So you can add the 7, subtract the y, or you could go the opposite way. So x minus y equals 7. If you went the other way, it's negative x equals negative 7.
Negative x plus y.
There we go. Thank you. Equals negative 7. Now, what do you put here?
0.
You put a 0 in your matrix because you have to have it hold a place. You can't leave it blank.
They always call it a placeholder.
I don't know. You would put a 0. So negative 1, negative 3, negative 6, negative 29. 1, 3, negative 1, negative 6, 1, negative 1, 0, and 7. So a one like this requires a lot of work on the front end. A lot, relatively speaking, right? It requires work on the front end to do that. But it's not hard. This is where I definitely would double check and make sure you have all your numbers in right. This is one of my favorite ways to solve a 3x3 system because it's easy. There's no eliminate one and then do another elimination later. Like it is super, super easy. What do you get for your answer on this one?
Call it in.
Do we hear that? It's not just me?
Yeah.
Okay. I don't know what that is.
That was weird.
That was weird.
Call the cops.
No.
File a notice.
It sounds like when you get those weather alert things.
Yeah, it totally sounds like that. Okay, questions on this so far? Okay, let's talk about weird stuff.
Well, let's not talk about weird stuff.
Yep. Nope, not an option.
You literally labeled it weird stuff.
I did.
That's what weird stuff.
No. I struggle with Sean being annoying. He sent him out of the hall.
No,
He actually is kind of.
I know. So really what you're trying to tell me is that it's Trevor.
Yeah.
Okay, so I told you this is weird stuff, but let me ask this question. Does it look like there's anything weird going on? No. So what that you're never gonna know before you put it into your calculator. That's not true. With one that looks like this, you're not gonna know if it's going to be weird before you put it into your calculator. Okay, it's gonna come out in the answer.
So you just know us.
Well, I want you to use your calculator because this is what you would do. You'll be like, oh,
Change it all now. Oh, wait, yeah, you do. It didn't change it that one.
yeah, but you're not changing it all around. You're just putting 0 in where it goes.
Whoa. That is weird. Either that or I did something wrong.
I did tell you it was going to be weird.
I don't know, it looks a little wrong though.
Yeah, you should know.
What's your look?
What's weird about it? Oh.
Oh yeah, that's what mine was
Holy
like.
shit.
Yeah, they're more vibrant.
Wait, time out, guys. Mine won't even work. Oh my-
Well, then black and computer.
I'm trying.
Oh, you should get this. Oh, the fact that it's messed up.
I don't know if she can do this.
Okay, so this is what I got. And I'm going to write this down so that it's written down for people who aren't here. 0, 0, 0. Okay, so what is it that we see that's weird?
There's no answers for X and Y.
It doesn't follow the pattern.
Okay, we got all of those things, right? All of those things correct. It does not follow the pattern. It should be, if we look back at our other answers, it should be 1, 1. There should be a 1 here. This should have been a 0, and this should have been a 0. So there's an automatic problem that we have going on. Now, if you look back, people who are not paying attention are going to be like, oh, x is 0.5 and y is -1. Okay. Look at the bottom though. What is if we put the bottom back into an equation, what does it say? No.
That nothing equals 1.
That 0 equals 1. This is no solution because 0 does not equal 1. Okay. But notice that falls out with some extra weird stuff. Okay. I want you to know that just because it looks weird doesn't mean it's no solution.
So wait, if all the if the diagonals all add up, like it's all like perfect, but they're all zeros on the other side, would that be infinitely many?
So if it was 1, 1, 1, 0, 0, 0?
Yeah.
No, that would be 0, 0, 0 is the solution. Right? Because x would be 0, y would be 0.
What if everything was zeros, then is it?
No. I'll show you. I'll show you what it looks like.
Yeah, sure.
Okay, so let's go -6x plus 3y minus 5z.
But it's go by so slow.
That's like a fever dream.
I love that the clock is like.
Well.
Well.
What happened?
I got my check back.
Oh, nice.
Oh, that's nice.
Yeah.
Did somebody find it?
How did it come to the school?
It was on the corner of M20 and Stone.
Oh,
Yeah.
was that where you lost it?
No.
Oh,
Did you lose my Spankies?
Yeah.
Can you shoot paper down?
Was there everything
Yep.
in it?
Everything but my shoes and my wallet.
oh,
Oh.
So
How much
whatever.
is it?
Better cancel the
Yeah.
But
Ew, who wants your stinky shoes?
exactly.
Yeah,
That's
that's
gross.
a good point.
My crash intensive shoes. They're like $20 on Amazon.
Oh.
So it's really not that much. Like what's the homeless guy?
yeah.
It's probably like a
But
homeless
what's
guy.
in your driver's license?
Yeah, I already went to Secretary of State and issued a new one.
Good.
Wow, so you like
I have a
lost
temporary license.
basically nothing.
Pretty much.
So-
Compared to what's in there, I
Cause
got really lucky.
the money in your wallet and did you already cancel your bank card?
Yeah.
Okay, so put this one in your calculator.
Did I miss anything crazy?
Oh yeah.
I just my card on me all the time. If a place doesn't accept tap to pay, the only time
It's
it's
what I'm here. Like,
Why did you tap it?
Is that
negative
-24
or
or 24?
I have my card.
Oh,
on my
on
phone.
your
Digital.
Oh,
It's down less.
oh, gotcha.
that -24?
That is 24.
Last one. You.
Yep, the last one is positive 24. It's just got some scribbles there.
Ellen, I don't know you remember.
Yeah, whenever I go to Walmart, I always gotta make sure to grab my card. I got that one there.
What the heck?
Mm-hmm.
Zero equals zero.
Okay, you guys, this is where I would, if you are not paying attention and you're feeling like this is a fever dream and you're sleeping through that fever dream, you should probably pay attention here.
And then that's just like, what are we doing? What
Whoops. 1, -0.5, 0, -4, 0, 0, 1, 0, 0, 0, 0, 0. Okay, so this is definitely off pattern. Okay, it does not have the ones where you're supposed to have it. So take a look at the bottom row. Is that a false statement? No. 0 equals 0, right? 0 equals 0. This one has infinitely many solutions. Now, this is where life is different than what we have done up until now. Okay, this is pre-calc as opposed to algebra 2. I mean, we didn't talk about matrices in algebra 2. Okay, this allows us to actually get the infinitely many solutions. So the way that we do this is we put this, so hang on, let me write this down. This means 0 equals 0 on the bottom is infinitely many solutions. That's not what you're going to actually write. So I want to put this back into a system of equations. Okay, so the first one would be what?
X minus 0.51 equals 24.
Equals -4. Okay, what's the middle one?
Z equals 0.
Z equals 0. Okay, so what we have to do here is we want to, there should be some variables that are simply single things that have a coefficient of 1. So I've got X and Z both have a coefficient of 1. So I need to solve for those. Z's done. I need to solve for X here because it has a coefficient of 1. Okay, so X would be equal to what?
Something.
4 minus 0.51.
Nope,
Plus.
plus,
Oh,
right? Because you got to add to the other side. And then Z is equal to 0, we know. Here is the problem. We need to have a Y. Okay, but Y is hanging out in X's equation, which is really not allowable. So what we do here is we magic up another variable. Okay, we're going to magic up a T, and I don't know why it's a T, it's just a T.
if you say magic and math, it's just
Okay,
magic of a
we're going to magic up a T.
This just proves that math is not magic.
So what happens, because what we want is we want everything to depend on not itself. Okay, so we can't have these guys interdependent. So what happens, because Y is here, Y is going to get replaced with a T. So I'm going to say I don't want Y in X's equation. I'm going to replace Y with a T. So I'm writing that down. The Y is a T, and then this guy is going to become a T. Okay. Now, on Friday, I'll talk about what does that actually mean, because it means something. Okay, and it actually useful. It's actually useful. So we'll stop there, and that'll be it. You have a quiz on Thursday. Do not forget, quiz on Thursday.
Oh, that's tomorrow.
That is tomorrow.